into parentheses x cubed plus 2x close parentheses to the power 6.
And we're asked to find the second derivative?
Yes.
Okay, perfect. Very good example. Stop me if you have questions anytime. So first, I cannot determine the second derivative if I don't determine the first. So anyone would like to help how to find the first derivative?
6 times x to the power of 3 plus 2x all to the power of 5 times 3x squared plus 2.
Very good. So thank you, Rita. This is now a product. And we have to use the product rule. So when we continue with the second derivative, we have to use the product rule. I recommend keeping 6 outside. It's a factor in front of a product. It's easier if you just forget about it for a minute, apply the product rule for this product, and at the end you can distribute. Okay, who would like to continue other than Rita?
So 5
Excellent.
x cubed plus 2x to the 4th power.
Good. Times the inner function prime.
3x squared
Plus 2.
plus 2.
Now I have to leave this one alone, but since they are the same, I'm going to put power 2 plus. I copy the first function, but now I have to differentiate the second one. Can anyone else tell us what is the derivative of the second function? Anyone else?
Would it be 6x?
Very good. And we close. Okay, now let's try and factor, because we need to factor and simplify. Here I cannot simplify. I will not raise this to the 5th power. It will take me forever. Of course not. This is fine. So now we have to factor out something that is common, and I have 2 terms. Anyone else would like to tell us the common factor and leave the 6 outside? Anyone else?
You could bring out x cubed plus 2x to the 4th.
Very good. X cubed plus 2x to the 4th power. Great job. Good. So now this is out. 5 is still in, and 3x squared plus 2 squared is still in. Plus, what is left from the second term? Anyone else that I haven't heard yet?
It'd be 6. 6x is left, so the derivative of that would be 6.
So let's look again. I agree with 6x. What else?
6 times x cubed plus 2x.
Yes, 6x because this is 5 and this is 4. So here I have to multiply by x cubed plus 2x. Do we all understand this? Yes?
Yeah.
Okay, perfect. So then the 6 stays outside, the x cubed plus 2x to the 4th will stay outside. And now, can anyone expand this for us? Somebody who hasn't said anything yet. How do we expand 3x squared plus 2? How many terms do we get? Noor, would you like to tell us how many terms we get when we square 3x squared plus 2? Okay, Haber, would you like to tell us? I think you are muted. Shivam, will you tell us how many terms we get when we square 3x squared plus 2? Michelle?
Is it 3 terms?
Of course. Good.
So it's 6
Squared.
9x,
Squared. Yes.
Yeah,
9x.
9 to the 4th.
Excellent. Plus 2
6.
times 2 times 3. Or if you want to say 6 times 2, that's fine too. And plus
Again.
4. Okay, plus. So we have 6x to the 4th plus 12x squared. Now I will distribute 5 and combine like terms. And this will be final. X to the 3rd plus 2x to the 4th. And then 45x to the 4th plus 60x squared plus 20. And then plus 6x to the 4th plus 12x squared. Everyone, yes, please.
So the MyLabs Plus had questions that were really similar to this, but it accepted like the factored form as the final answer. Is that correct for a test, or do you need it like?
I will make sure that it's clearly stated that you have to fully simplify it, and you will see why in the next chapter.
Okay.
I'm doing all this for the next chapter, so it will tell you. Yeah. Okay. So finally, we have final form. So from here, oops, I go here. So the 6 stays outside, x to the 3rd plus 2x to the 4th. Now, on problems with powers like -3/2, I'm not going to do this. I'm not going to even think of doing it. But here, everything has nice powers. So I have 45 and 6, which is 51x to the 4th. And I have plus 72x squared and plus 20. This is the final simplified form of the second derivative. Okay. Any questions here? Okay, so let's go back to our, I still have one tiny bit of explanation from, as I promised, from the last section of chapter 1, and we start chapter 2. And that is a very important theorem, if you want, or rule. It's called L'Hopital's rule. I think he was French. So he said this. First of all, 2 conditions. Only if we, or when we calculate a limit. If there is no limit operator in front, L'Hopital's rule is not applicable. And there is a second condition. Only in the situations of 0 over 0 or infinity over infinity. So if both conditions are fulfilled, we are looking at a limit. And the indeterminate cases, these are called indeterminate cases or situations. Only in these 2. There is a total of 7. But in this class, in my calculus class, I present all 7. But in this class, we only need to look at these 2. And in any event, the other 5 are not using L'Hopital's rule unless we change them into these. So L'Hopital's rule is applicable only to these 2 situations. And I want us to look at a couple of examples, because I haven't explained the rule yet. So if you like to open on page, it's the very last page, page 175. Page 175. So I would like to start with 76. So that's a limit as x approaches -2 from x squared minus 4 divided by x plus 2. And yes, now I know you're going to say, why didn't we learn this at the very beginning when we studied limits? Because we didn't know what the derivative was. So we had to wait till the end of chapter 1. Okay, so Ready? Can anyone tell us how we start when we determine a limit? What is the first thing we need to do? Always. Exactly, plug it in. Good. So if we plug it in, what do we get?
It does.
That
It would be 0 over 0.
right, which is one of the situations in which we can apply L'Hopital's rule. So please do not say that any number but 0 over 0 is indeterminate. No, this is undefined. So 0 over 0 is an indeterminate case. Okay, L'Hopital showed the following. He said this: if you have a limit and initially you run into one of these two indeterminate cases, which we did, so both conditions are fulfilled, then you can simply differentiate the top. Can anyone give us what is the derivative of the top?
2x.
Very good. What is the derivative of the denominator?
1.
Good. So what is the answer then?
2x.
2x.
So we got to derivatives and we forgot how to determine limits.
-4.
Thank you very much. Done. So never say that 0 over 0 is an indeterminate case. It's an undefined case. Never say that 0 over 0, we talked about that, will never exist. We always said that 0 over 0 has potential or has hope. Also, infinity over infinity has hope. And it turned out that this is a very straightforward situation now. And yes, I know you would have loved to know this at the beginning of the class when we talked about limits, but we couldn't because we didn't know how to differentiate. Okay, here's another example. Any questions on this? It's pretty nice, right? Okay, so let's say 81, same page, 175. Let's do this together. So limit at x approaches 2, and the numerator is x cubed plus 5x minus 18, everything divided by 2x squared minus 8. So first of all, it's a limit, right? So as we said, we have to do what first? Yes. So please tell me what type of indeterminate case this is. If you find that it's 1 over 0, I cannot use L'Hopital's rule. If you find that it's 10 over 0, I cannot use L'Hopital's rule. Only if you find 0 over 0 or infinity over infinity. If one of these two pops up, say it again.
It's 0 over 0.
I agree, it's 0 over 0, right? Because this is 8 minus 18 is negative 10, and this is 10, so definitely 0. And this is 4 times 2, which is 8 minus 8 is 0. Good. Can I apply L'Hopital's rule? Yes or no?
Yes.
Good. So let's differentiate. So I want to make sure that you understand that without this limit, when I differentiate this, I cannot differentiate the top and differentiate the bottom. I have to use the quotient rule. But inside a limit, and only if I have this or this, I can differentiate the top by itself and the denominator by itself. Only in those two conditions. This and this, or this and this. Good. So the derivative of the numerator, please.
3x squared.
Excellent. Good. And the denominator?
4x.
Good. What happens now? I have to plug in again. If it happens to be 0 over 0, I'll continue again. Differentiate the top and differentiate the bottom. But if it's not 0 over 0 or infinity over infinity, I cannot. So what do I get then? Very good. 17 over 8. Done. Pretty nice, isn't it? L'Hopital's rule. Okay, let's look at one more, and that's good enough, I think. So this is limit as x approaches infinity from 4x squared plus x minus 3 and everything divided by 2x squared plus 1. So what do we need to do first? So what do we have in the numerator? Noor, are you back? Haber, are you back?
I never left.
It would be
Well, I asked you a question and I haven't gotten an answer.
Oh, I didn't hear my name.
Oh, okay. So what do we get?
on the bottom. It would be 4x. On the top.
We haven't checked the conditions. I cannot do anything. I will
If you
not.
do you plug infinity? I've never seen plugging infinity. in.
Very
Is
good
that what you want us
question.
to do?
Very good question. So when we talk about x approaches infinity, which of these three terms really counts?
None.
None of them.
As long as it's not.
What do you mean?
multiple.
What do you mean? Which of these is the most powerful one? What do you mean? Doesn't none of them?
But adding infinity to infinity doesn't change it, I thought.
But infinity squared, wouldn't that be tremendously bigger than infinity? Which of these three terms is the most powerful term? Good. So where does it go? When x approaches infinity, where does 4x squared go?
Infinity.
Good.
Times infinity.
Good. Which is the most powerful in the denominator?
Right.
2x squared
Where does it go when x approaches infinity?
to infinity.
Good. So we do have a limit, and we did find the infinity over infinity situation. Now we're ready to apply L'Hopital's rule, because we can. So limit as x approaches infinity. Now I can differentiate the top. What do I get?
8x plus 1,
Very good. What do I get in the denominator?
4x.
4x, very good. I plug in infinity again. Where does the numerator go?
To infinity.
Great job. I plug infinity. Where does it go? Excellent. So I have a limit with the situation infinity over infinity. I copy the limit. What is the derivative of the numerator? How much? Good. So what is the limit? 2. Very important. That means that y equals 2 is a horizontal asymptote. Right? We're going to discuss this further in chapter 2. That's all I had to say about chapter 1, and now we can start chapter 2. Any questions?